Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on the topic of triangles. In previous part we saw the congruency. So what do we mean by congruency and the conditions or the necessary conditions for how to set up that two triangles are congruent. We saw side, 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 we saw side, side, we saw angle, angle, side, and angle, side, angle. We also saw right angle, the hypotenuse, and the side conditions. Okay, I hope you recalled all of these. So let's just directly jump to next, and here we will be continuing the discussion on congruency. Okay, now congruency relation in set of all triangles. Let's see. So by defining by the definition of congruency of two triangles, we have the following result. Let's see the results. As we all know that a given triangle is already congruent to itself. Yes, it is by just definition. Okay, and if say that two triangles are congruent, that means a triangle ABC is congruent to triangle DEF, then I can rewrite it as or I just can manipulate my words to say that triangle DEF is also congruent to ABC. So either you can say triangle ABC is congruent to DEF, or you can say DEF is congruent to ABC. I hope this is clear. Let's move further. In third, if ABC is congruent to DEF, it is given, and it is also given that DEF is congruent to PQR. This means if say that I have three triangles A, B, so this triangle is 1, this triangle is 2, and this triangle is 3. So at first we are saying that this both the red and the green one are congruent to each other, and next we are saying that this green one and the purple one are congruent to each other. I hope this is you are understanding now. We can take a single piece of information, and that piece of information is this, that the 1 is congruent to 2 and 2 is congruent to 3. That means 1 is also congruent to 3, as you can see, because all of the triangles are congruent to each other. So I can also say that the red one triangle is congruent to the purple triangle. So if two triangles are congruent, then their corresponding sides and angles are also congruent by CPTC. What do we mean by CPCTC? This means corresponding parts of congruent triangles are also congruent. Okay, do please remember this CPCTC full form. Okay, let's move next. Let's see the theorem. Theorem given is angles opposite to equal sides of an isosceles triangle are equal. This means we are talking about, first of all, we are talking about isosceles triangle. This means we are having two sides equal in length in a triangle. Say this blue sides both are same in length, and this purple side is we don't know it is equal or not to that of blue side. So what? So the my theorem says that angle opposite to the equal side. So this is my first side, okay, and this is my second side, and the angle angle opposite to equal side is this, and for this side it is this. So these two angles must be equal to each other. So this A, B, C. So we know that AB, this AB and AC both are equal. Yes, AB and AC both are equal, and we have to prove this angle, angle B, is equals to angle C. So this angle C. I hope the diagram is clear to you, and the theorem what it says is also clear to you. Let's see. So first of all, we draw a bisector. So in order to prove, we are doing some constructions. Okay. So we are given a triangle ABC. Okay. So we are given a triangle. So let me draw a new triangle. So from which you can easily understood what is happening. Okay. So this is my ABC triangle. Okay. Now what we are given is this side is equals to this only. We are given with this information only. Okay. Now what? Now we draw a bisector AD of angle A. So we know this is my angle A. Yes, angle A, and I am going to draw a bisector of this angle. That means I am going to join this point to point on this line, say this, in such a way that after joining this 2 points, this angle A is now divided into two parts, and both of the parts must be same. So this part, one part is this and another is this. That's what we mean by the bisector. So we draw the angle bisector of A. So this angle, if I say this point as D, then angle angle ADB must be equal to this angle, which is angle A, not angle DAB, and this is angle DAC, and angle DAB must be equals to angle DAC by construction. Okay, by construction, because we constructed in such a manner that these two angles must be equal to each other. So angle DAB is equals to, or must be equals to, angle DAC. So this and this. I hope this is clear to you how we are approaching. Now what? Okay, I hope this is clear. So I am going to name this point as a D. Okay, now let's see two triangles. What I am having, two triangles. So one triangle is ADB, and another triangle is ADC. Okay, so if you see that we know that this length is equals to this length in the another triangle. So this means that AB is equals to AC. Okay, now what? We also know that AD is equals to AD, because both the sides AD is just a common side in both of the triangles. So common side in both of our triangles. So both triangle, what I am referring to, this ADB triangle and ADC triangle. Okay, so now what? And we also know by construction that angle DAB is also equals to angle DAC. So if you see another diagram for this triangle will look like this. Okay, so say my triangle will look like this, and this is the angle bisector. So my one triangle is this. Okay, my one triangle is this. Okay, and another is in gray part. Okay, and we know the orange triangle, this side is same as the black triangle to this side, and we know this angle is also equals to this angle. Okay, and we know this is the common side. So I am using the side angle side property, or the condition, to say that this orange triangle is congruent to the black triangle. So I will write my triangle ABD is congruent. ABD is congruent to triangle. So ABD is congruent to triangle ACD. Okay. So ACD. I hope you are clear with that. Now from this I can say that because these two are equal in length, okay, now what? I have come to this that both of my triangles are equal and congruent. Now what? So triangle ABD and ACD, we have AB. These condition I have already told you. Okay, so just saying. Okay, so let's see. So by you already saw that by side criteria, angle triangle ABD is congruent to triangle ACD. So this there is some error in text. I hope you can understand. Okay, now let me give you more explicit reason. So this is what so far we have done. Now what we will do? It is just simple. We know if two triangles are congruent, then their congruent parts must be equal to each other. So this means that this side, the angle between this side and this side must be equal to the angle between this side and this side, because by CPCT, the congruent part of the corresponding part of congruent triangles are congruent. We know that this is equal to this and this is common, and the leftover side also must be equal to the other leftover side in the another triangle, which means this side must be equal to this side. Okay, we know this angle is equals to this because this angle is in between this single stick and the double stick. Now the angle in between double stick and the 3 times stick will also be equal in measure. So this angle must be equal to this, and the remaining angle must be also equal in measure. So for example, not for example, in this theorem, so we proved that the angle B is equals to angle C by CPCTC. Okay, I hope the proof is very clear to you. Let's see another theorem. Okay, so here the theorem 2 says that if two angles of a triangle are equal, then sides opposite to them are also equal. This means, let me draw so that you can understand. So if two angles of a triangle are equal, okay, so two angles of a triangles are equal, then sides opposite to them are also equal. So this, if this happens that this angle is equal to this, then this means this opposite side are also equal in length. That means this side is also equal in length. So what is given here is that if you take ABC, we are now given that angle B is equals to angle C, and we need to prove that AB, this side length, is equals to this side length. So this is just not if you connect by the theorem 1, you can see in the theorem 1 we talked about the length is already equal, then we say the angles are equal. Now in this theorem we are saying angle, if angles are given and both the angles are equal, then the opposite side to those angles must be equal. So we will combine and say something new. You will see. Okay, so first of all, let's prove with step by step. So ABC is equals to AC, we need to prove. So it is quite easy. So first of all, we construct and we draw the angle bisector of angle A. So we just draw this line AD in such a manner that this angle and this angle both must be equal to each other. Okay, I hope this is very much clear to you. Okay, now what? Now, yes, now I have two triangles. One is this one. Okay, and the second is this one, ADC. Okay, I have already given that angle B. Okay, angle B is equals to angle C. Okay, I am comparing two triangles. What triangles? Triangle A, B and D, and triangle ACD. I am comparing these two triangles. So from this triangle I am taking angle B, and this triangle I am taking angle C, and both I also this piece of information I have also given that angle B is equals to angle C, and the length AD is equals to AD because this is common. Okay, common, this is given. Okay, now what? Now what I have is other piece of information is this, that this angle, the angle BAD is equals to what? Angle CAD. Okay, now I know that this angle is equals to this. Yes, indeed, this is true, and this side is common, and this angle is equals to this angle. So I will apply angle side. In angle side, if you have two triangles with two angles equal to each other and the one of the side equals to each other, then I can use this and say that both of my triangles are congruent to each other. So using AAS, I will say that my triangle ABD is congruent to my triangle. So I am going like this. So my triangle say ABD is equal to ACD. Okay, so or congruent to ACD. I hope this is clear to you. Now from this, if you see using corresponding part of congruent triangles are congruent, I can say that this remaining angle must be equals to this, and the angle or the side between these two angle must be equal. Okay, so this means this BD equal to DC, and the angle between this purple and the red one, the angle between, sorry, the side between the angle purple and the red one must be equal in length to the in the another triangle of the same or the corresponding angles, which is red and the purple. So this means this side AB is equals to AC. So this was the thing we need to prove. So hence we proved by CPCTC AB is equal in length to AC. I hope this is you can understand, or just see from this AB is equals to AC and BD is equals to CD and AD is equals to ED. I hope this is clear to you. Let's move to next and we'll see more theorem. Now, first of all, you saw in theorem 1 that if length is given, if this is given, then this is also equal. So this is also equal. This also equals. Okay. Okay, and Theorem 2 gives, if my triangle is given and the angles are equal, these angles are equal, then the opposite sides of these angles, which is this must be equal. So this must be also equal. So from this you can say that in isosceles isosceles triangles, okay, we have a property that is, the if this is my isosceles triangle, then these angles must be equal in length. Okay, always remember this property. Okay, so using this two theorems, I can say that that in isosceles triangle, that means the two sides are must be equals to each other, and opposite of those sides, the respective angles also must be equal. Okay, now let's see theorem 3. In theorem 3, if the bisector of the vertical angle so we are talking about the bisector of the vertical angle bisects the base of the triangle, then triangle is isosceles. That means if my triangle is like this and vertical angle, okay, so what vertical angle I am talking about, you will see, if the bisector of vertical angle bisects the base of the triangle, that means this say this angle is my vertical angle, and if the bisector of this angle, let's say I'm drawing a bisector of this angle, this means this angle is equals to this, and this line is also bisecting the base of the line, that means this length, say let me name it ABC. Okay, so this and this point as D, and if this is going to happen, that BD is equals to DC, then I will say that my triangle is isosceles triangle. I hope you understand what is the theorem talking about. Okay, let me once again provide you what my theorem is saying. Okay, so a triangle is given. Okay, so let me provide you the information which is given. Okay, and this is my vertical 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 angle. Okay, vertical angle. Okay, this is my vertical angle. If the bisector of the vertical angle, okay, so let me draw the bisector of vertical angle. So bisector means dividing my this angle into two equal parts. So let me divide. So this is my bisector, and this bisector will intersect this base of triangle. So this is my base of the triangle. Okay, this is my base of the triangle, and this green line will somewhere cut this base, say this at this point I am naming it as D, and my triangle was ABC. I hope this all information is very clear to you. Okay, and from this you see that this angle is equal to this angle, because this green line bisect the whole red A angle. So this angle was uh, bisected or divided into two parts which is equal. Okay, so this angle and this purple angle. Okay, so angle BAD is equals to angle CAD. I hope this is clear to you. So this all information is given to me. Okay, now there is plus information. If you see that this line is now also bisecting the base of the triangle, which means that this BD length is also equals to DC, because this my base is BC. Yes, and this green line also bisects my base. Base is BC, then BC is now divided into two equal parts, saying BD is equals to DC. I hope this is also clear. So this all information is given to me. So this is given to me, and I need to prove that the triangle given to me in this case, in the drawing I made, is, I will say that triangle ABC is my isosceles triangle. I hope this is very clear to you. Okay, so how we will prove? Don't get too confused with the terms. Just follow the theorem and my instruction. Do not get confused with the words and the language here. Okay, so just follow my lead. Okay, now we have to prove that this my red triangle is my isosceles. So how I am going to prove that? In order to prove isosceles triangle, what we need is that the length of two sides, any two sides, must be equals. Okay, so let's see how we will do that. So if you see that this in two triangles, what triangles I am talking about? I am talking about this one triangle is this, and another triangle is this. Okay, so please pay attention, and we know that BD is equals to DC. Yes, we know that AD is common. Yes, we know that what we know other thing is that this angle A, this purple angle in this triangle ABD is equals to another purple triangle in the other triangle, which is uh, in triangle ADC. Okay, now what? Now from this, if you see, let's see what we can take information out. It is quite easy that we will be using some one of our conditions. Okay, so recall the condition. One was, we learned 5 conditions. So the side angle side, angle side, angle, and what we did is right angle and the hypotenuse and the side. So here what we can apply? So if you see, you cannot apply any of this. Why? Because you are given side and angle. Is there anything like that? Side and angle, we know about side angle side, but we do not know about side angle. So how will we do? So just let do some construction. So what construction we will be doing? Let's see. So to do a construction, let's see here. So just nothing. In the previous we do the construction is just extending the E line in such a manner. Okay, so now here if you see, okay, my triangle was like this. If you recall, let me draw with the same color. Okay, so this and this. So here A, B, C was there, and I made this as my D point. So here and here, this was equal to each other, marked by purple color. Okay, and I know this BD is equals to this, and this is my common. Okay, now what? Now I just introduce new point E in such a manner so that this AD will be DE. So this length, so this point is E. So I constructed this E point in such a manner that this length my length, this DE is equals to AD. Okay, so this length AD must be equals to DE. So I constructed this E point in such a way. Now see this triangle EDC. If you try to see it, let's see together and make take some analysis and take some points out of it. So from this, if you see, you have this length. Okay, this ED equal to this. Okay, and now what another thing we have? We have this side as common. Yes, we have this side as common side. So this DC is my common side. So this side is common and this is already equal in length. Okay, okay. And now what? Now how will we proceed? So how will we proceed is quite a simple. Just see the vertically opposite angles. Okay, so what vertically opposite angles I am talking about? Let's, if you see the ADB and angle CDE. So ADB, ADB. So this angle, this ADB is equals to this angle. Yes, because these are my vertically opposite angles. So always keep this point in mind, that vertical opposite angles are always equal to each other. Okay, I hope you are getting what I am drawing. Okay, now what we know? Now we know that both of this angle is equal. Okay, now what? If you see that this side is equal in length in this side, yes. This angle is also equal to this angle, yes. This side is also equal to this side. So from this I can say triangle. So I can say triangle A DB is a congruent to triangle DE. Say AD, I am going AD. So ED, not DE, it will be ED to C. ED to C, because if you see AD is equals to ED, yes, by construction, and DB is equals to DC, because it is because this AD line bisect my BC base, yes, and angle BDA is equals to angle CDE, because vertical opposite angles. Okay, so from this I can say easily that what I can easily say is this, that a side angle side, so side angle side, by using side angle side, I can say what I can say, that it is AB. AB is equals to EC in length. Okay, so this piece of information I have taken. So from this I can easily say that, so AB is equals to EC we have now gotten. So let's move and see what next thing we can come up with. Okay, so here if you see, by corresponding part of the corresponding part of congruent triangle are congruent, I can easily say that in the from the previous diagram, BAD is equals to CED. And but if you see that BAD is equals to angle CAD, and CAD is equals to CED. If you recalling the diagram, let me draw for you again. Okay, so this was my diagram, looks like A, B, C, and this point was D, and this point was our E. So here we are talking about BAD. So BAD is this, and CED is this angle. Both are yeah, equal because of the congruent part of corresponding part of congruent triangles are equal. And BAD, AD is also equals to CAD. We know that because we drew the bisector for the angle A. Okay, so this means CAD, this angle CAD, this orange angle is also equals to the orange angle CED. Okay, I hope this is clear. Now AC is equals to EC. So AC, if you see this, AC is equals to EC. Okay, why? Because if you use theorem 1 and theorem 2, you will see that the angles both are equal in triangle, then the opposite side must also be equal in length. So this means AC equal to EC, and this further implies AC equal to AB. Okay, AC is equals to this AB. Okay, I hope this is now clear to you. So that's it for today. We will meet again soon for the next topic. So thank you for this session. Thank you.